Hello, my name is Sage Parekh and this is Physics, Lab 1, Constant Velocity. The purpose of this lab is to apply Newton's laws of motion in real life using position time graphs. In this lab, we will compare the observed position of an object traveling at a constant velocity to a predicted position calculated from a computational model. How far will the observed deviate from the theoretical? Which is the code. Hint, hint, it will deviate. The fundamental principles in this lab are Newton's laws. Newton's first law states that an object will remain at rest or at constant speed unless an external force acts on it. Newton's second law states that the net interaction between the system and the surroundings, which is the net force, to the observed motion, change in momentum. Newton's second law's equation is F net equals change in position divided by change in time. From this, we can get to the position update formula, which is right here, and also the velocity update formula, which is right here. The procedure in this lab is to record a video of a marker, which is our system, moving straight horizontally at a constant speed. Our surroundings are the force, gravity, and friction, which will not be accounted for in this lab. We'll talk about that more later. Using Tracker, we track the position of the marker at different time intervals. And then to find the theoretical, we use code in GlowScript to create a computational model of the marker. And then we make a position time graph for both theoretical and observed in Excel. Assumptions. So our assumptions are that there is no friction, zero net force, and no air resistance. We are having these assumptions because we are performing this experiment assuming that the system is moving at a constant velocity. So friction, net force, and air resistance will interfere with a constant velocity. Using Tracker, we found the time and position of the marker. We placed a point at the center of mass of the marker, and here's the video. Using Excel, we graphed the time, which is x, and the position, which is y. And we got a slope of 0.0576, and we got a y-intercept of 0.0016. There are images of code that we used in GlowScript to find the theoretical position of the marker. Our initial position was our y-intercept. Our velocity was the slope. We both found those in Excel. Our deltat was 0.01 because our video was recorded at 100 fps. We also used the velocity update formula, and we also used the position update formula in our code. This is the graph that was shown in GlowScript after I ran the program. In comparing the two, you can find that there is a deviation between the code and observed. The code is above the observed. Are there errors that could explain these deviations? Well, yes. Surroundings such as friction and the presence of air can interfere with the data. Also, tracking. Using our fingers, we place the center of mass in the tracker. Lastly, let's talk about the what-ifs. If the positive x, which is the position, was changed to negative x, what would happen? The slope would also be negative, meaning the line on the graph would point downward. Is the net force equal to 0? The observed model and the code model do not match, so there are other forces at play, such as gravity and friction. It is not possible to identify the number of pushes and pulls required to obtain a zero net force.